In this lesson, we will go through a more difficult example problem involving gas mixtures. Let's take a look at our problem. Calculate the total volume of gas produced when 0.1 kilograms of nitroglycerin decomposes according to the equation below at 85 degrees Celsius and 90 kilopascals. Let's note down the information we can gather. The first thing we can gather from the problem is that the mass of nitroglycerin is 0.1 kilograms, which is equal to 100 grams. Secondly, the temperature is 85 degrees Celsius, which is equal to 358.15 Kelvin. And lastly, the pressure is equal to 90 kilopascals. Now, to begin solving for our products, the gases, we must determine how much of our reactant, the nitroglycerin, we have. We'll determine how many moles of nitroglycerin we have by using its molar mass. In order to first calculate the molar mass, we'll add 3 times the molar mass of carbon, which is 12 grams per mole, plus 5 times the molar mass of hydrogen, which is 1.008 grams per mole, plus 3 times the molar mass of nitrogen, which is 14.007 grams per mole, plus 9 times the molar mass of oxygen, which is 16 grams per mole. This gives us a total molar mass of 227.1 grams per mole. Now to determine the number of moles. We'll take our 100 grams of nitroglycerin and divide it by its molar mass, 227.1 grams per mole. The grams of nitroglycerin cancel out, and we're left with 0.44 moles of nitroglycerin. Now that we have the number of moles of reactant, we can use this to determine the number of moles of product. In this case, we're looking for the total volume of gas produced. Since all the products in a reaction are gases, this means we're looking for the volume of all our products combined. To do this, we need to first determine the total moles of gas that are produced. For our mole ratio, the chemical equation tells us that our reaction produces 6 moles of nitrogen gas, plus 12 moles of carbon dioxide, plus 1 mole of oxygen, plus 10 moles of hydrogen gas. This gives us 29 total moles of gas. We can now use this to determine how many moles of gas are actually produced in our example. We do this by multiplying our 0.44 moles of nitroglycerin by the mole ratio from our equation, 29 moles of gas for every 4 moles of nitroglycerin. The moles of nitroglycerin cancel out, and we're left with 3.19 moles of gas produced. Now on to our final step, determining what volume these moles of gas are equal to. To do this, we'll use the ideal gas law along with the law of partial pressure, which tells us that the total volume of a gas mixture is equal to nRT over P, where N is equal to the total number of moles of gas. We can now substitute the variables in this equation with our known information. Performing this calculation, we get a volume of 105.55 liters.